Mrs. Loeb, you ready?
I'm ready.
Okay, I'm ready too. We're gonna save the planet. Here we go. Kids, hunker down. The Earth is going to be at a certain location. Wait, I have a dice block. Here we go. Let's see where it goes. It's at 0, 9. And the meteor is gonna be at 26, comma, whoa, 19. Fun times. All right. Our mission, if you choose to accept it, please accept it, is to shoot a rocket at the meteor. We've already set this up before in previous lessons. And we have to destroy it. So we have to choose the right trajectory, the right direction to shoot from the Earth to the meteor. And we have the 2 locations in space right here. So let's go ahead and take most of the guesswork out of it and just do y minus y over x minus x like I have in the template, so we can find the slope, which is the right direction. So y minus y. The first y is 9, the second y is 19. I need you to note that the order doesn't matter as long as you're consistent. So if you want to do the second y minus the first y, like 19 minus 9, to keep that positive, because clearly it's a positive slope, that's okay, as long as you do the second x minus the first x. So 26 minus 0 on the bottom. So this would become 10 over 26, like that. And of course we can simplify, so please do so. Divide both by 2. That's 5 over 13. So your slope is 5 over 13. Now here's the thing, we have a new idea that we're incorporating into a starting value. So the Earth is not at 0, 0, as you can see, so it's not a proportional relationship. If you fire from 0, 0 and go up 5 over 13, you will miss, okay? You will be down here somewhere underneath the comet. We have to raise that up to 9 as a starting value. And to do that, that is the y-intercept, is what we call that. It goes at the end of slope-intercept form. So y equals your slope. Go ahead and drop your slope right there, right? That is your 5 over 13 in the equation. And then the plus 9, because see how it's at 0, 9, that's the location on the y-axis, 0, comma 9. None of this, 9 units up. 9 goes here. And now we're going to chart our progress of the rocket along the way. So if you start at 0, comma 9, and you fire at a slope of 5 over 13, the 5 goes in the y direction. So you're going to add 5 onto the 9 to get 14. And the 13 gets added onto the x. Now, if you might notice, this would place us exactly like halfway between the Earth and the comet. So you'd be right in here, right? Sitting right where that arrow is. You have to do another 5 over 13. So up 5, again, put you at 19. Over 13, put you at 26. And you might notice that we're at 26, comma 19 with the right trajectory and the right starting point. Humanity is saved. Thank you. Mrs. Logue, are you relieved?
Yes.
Oh, okay, me too. All right. I was worried about you. I didn't know if you could do it. But let's try again. Okay. Can you see that okay? For all of humanity. 0, 10. All right. It's a 30-sided dice ball. That's right. It's fun. But we got a 21. And the next number is 2. Well, that can't work. Because if it's going to be a positive slope, it has to be greater than 10. So I'm going to keep rolling until I get a number greater than 10. How does that sound? Like 12. Beautiful. All right. Follow your process. I have the template here. Take the y's and subtract them. Do you want to do 10 minus 12 or 12 minus 10? 12 minus 10? I like it. I bet nobody said anything, but it's okay. You can talk. No, you shouldn't. You should listen to me. 21 minus 0 in the x direction. So I did y2 minus y1 and x2 minus x1. There we go. Do the work. So that's 2 over 21. That's your slope. Drop that into your template for the equation, which goes here. And then the y-intercept is the starting value on the y-axis of the Earth. In this case, it could be anything. It could just be where you cross if it's meaningless. I like to have meaning, so this makes it more fun, I guess. Put it's in. All right, here we go. In your table, let's track it. 0, 10. Increase by your vertical change, which is the top number. That's a 2. So it goes up by 2, that's 12. The bottom number is 21. And since this didn't simplify, we are there after one iteration of the slope. You're there, right? 21, comma 12. Yes, you could keep going with this. You could continue to add 2, stair step it, right? And get 14. And then add another 21, which would be 42. And so on. You can continue to do that for as long as you want. All right, hang with me. About halfway through. Okay. Now we're going to position the Earth still on the y-axis, and it can be whatever number it is. But then if we're down here, I want to pretend like we're in quadrant 4, where it's positive, negative. So whatever I roll for the y value, we're going to stick a negative on it, just to try to get a variety of places or locations where the meteor is coming from. Okay. So the Earth is going to be at 0, 13. First number is 5 for the meteor. And whatever comes out of this will be negative. Negative 3. Okay. But even though it's positioned differently, the template or the process is still the same. Take y1 minus y2, or vice versa, just be consistent. I think this one, let's go ahead and do that. Let's go y1 minus y2. So 13 minus negative 3. Did you hear the minus negative? That means you gotta do the KFC. You gotta do the additive inverse. Okay, we'll do that eventually. And then 0 minus 5 on the bottom, or in the denominator. All right, numerator. There it is, plus positive. That's 16. And then here we have a negative 5. If it is an improper fraction, do not change it to a mix. I like the slope with the 2 numbers with the 16 and negative 5. But if it's negative, you may remember this from class, I like to bump the negative to the top. So go ahead and give the negative to the 16, like that. I like to drop first. So from the Earth, we're going to drop 16, and then we're going to run over 5 on our horizontal. Put that in the template. You might see that down here. The slope is negative 16 over 5. Where you begin on the y-axis, which is 0, 13, goes here, so 13. And now we're going to track our progress along the way. 0, 13, in the table. Vertical change is the top number. Now that's a drop, isn't it? Negative 16, so 13, drop 16. Where does that put you? Negative 3. Horizontal number is just plus 5. You're at 5, negative 3, which is good. Okay, that's where we need to be in order to save humanity one more time. Miss Lowe, you ready for the last one?
Yes.
Okay. Give me a number between 0 and 20.
18.
Why did you choose 18?
I like 18.
You like 18? Okay. Was that your number in college?
No,
or
my number
high
in
school?
college was 11.
It was 11. Why did you pick 11?
I don't know.
Oh, okay. Well, 18's fine. We'll go with 18. All right, I'm gonna roll for the other 2. Oh no! It's okay. It's a 23. 23 goes here. Whatever number this is, I'm gonna make it negative. Negative 8. Here we go. Excuse me. Subtract the y's, put them in the numerator. You can go ahead and do y1 minus y2. That's totally fine. So 18 minus negative 8. I heard that again, minus negative. And then 0 minus 23 in the denominator. Go ahead and do the additive inverse. That's 26. And 0 minus 23, of course, is negative 23. And I just said if the negative is in the denominator, go ahead and just bump it to the numerator. I like to drop first in my slope, so I want to go down 26 and go over 23. Stair step it. All right, everybody see that okay still? Oh yeah, we should be fine. Put that slope into your equation. It always goes in front of x. Right? It's slope, it's the rate, it's how fast you're going. It's also direction. Okay. And then y-intercept. 0, 18. 18 goes here. Track your progress. Start at your y-intercept, 0, 18. Do your vertical change, which is negative 26. So you're going down 26 from 18, which I believe is negative 8. And you're going to go up 23 on your x value, which is 23. And you will successfully hit the meteor. Take that. 1 second. Okay. Apparently, I got you guys coming in, and I gotta stop this. But that's an awesome lesson on saving the awesome planet. So please do well with your exit slip, and make sure you fill everything out that you need to. You're gonna turn those into the tray, and then you can work on the Desmos activity.